about the yeah, and then how we can able to converge it into the single Slurm header. That's one thing, and then also I'll take you through the demo walkthrough as well. So on the left hand side, on the right hand side, you can actually see there are three campus. I just assume that campus A, campus B, and campus C, and each of them have H100. Of course, one of the H100 is already MIG sliced, but one of the H100s is actually full GPUs already available, and each of them have the Slurm head, and each Slurm head is actually provided with 10 TB attached. So that's how the existing architecture looks like. So what we can actually do is we can actually come up with either if you want that 30 TB of data, then we can put 30 TB also, and you can create a namespace with the split, whatever the storage that you can come up with. One Slurm head will be there, and this Slurm head we can have like multiple partition. So these partitions will be catered to campus. How many campus that you have, that it comes under the partition. So under the partition, you can define your GPU resources, and you should be able to, whatever you can able to do it with 3 different config files, you can able to do it with single config file also. So that's what you see it in the table. For the job submission, 3 separate endpoints. Instead of that, you will have single SBatch endpoint. SBatch comes from this single head node. And if you want to do cross-campus visibility also, admin from Srinivas said also you can able to just do the SQ and see everything from the single node, instead of going for each node and see all the list. And then it's a admin overhead can be reduced, and of course the fair share trading also can be done. Instead of per cluster, it is a global level. So what is the config that it actually looks like to configure this? So for the partition, you can see that this is how we create a partition. For example, campus A, campus B, campus C, and each campus we provide with the GPU nodes, the host name itself. And each node, there is a allow accounts is there, which means we are explicitly telling we are creating an account, and each account will have a user. And for example, user A, user B is there, and only that account is allowed to access that partition. So even though that user is outside, let's say user C is coming and he is actually not allowed in this partition, and he cannot be able to access that. Right. So this is from the account GPU level, and then user level management, and you can actually put the QoS also. So for each campus, what is the GPUs and what is the per user you can actually do, and what is the priority. So this is the QoS level, you can manage it. And then storage is the namespace part. For example, there 10 TB is actually allocated for each storage. We can converge it into the 30 TB and create a namespace and share it across with the partition also.
All of these individual ones will be VMs.
Yes, correct. Right now it is all in the slurm.config separately. Now we'll have one slurm.config file where all of these things are mentioned.
And how do they exactly map behind it?
Oh, okay, that is physically we actually provide, whatever the slurm head we provide, that has the physical access to your GPUs. So today.
But I mean, will both the GPUs be on the single node, intra nodes?
Okay. So if you take this example, each H100 GPU is actually virtual machine for you, but you cannot actually. We need to go back and check the exact address, basically, but you cannot be guaranteed. There is no guarantee that whenever you reserve, I'll show the demo. Whenever you reserve that VM, I cannot give you the guarantee that it is always be in the same VM or not, unless, for example, you give me like 8 GPUs that I want, then I can actually go and specifically pick a node which can able to have like 8 GPUs are available, and then I can provide it. But if you go by one reservation, I cannot give you the guarantee, because let's say my other customers who actually reserved 4 GPUs in a single node, and you are going to come with asking for one more GPU, and I may give that 5th GPU which is available in that node. So technically you are sharing with in a single, but it is a logically different tenant for you, but you are actually in a single node.
Okay, no, I guess my question is more on the side of, say, the H100A1 to H100A2.
Yeah.
What exactly would be the communication? So it will go.
Yeah.
H100.
So either it will go through my Rocky V2, the 400 Gbps of the bandwidth, or it is through the GPU to GPU communication, which is higher, NVLink. Is that what your question?
Yes.
So that is what I'm saying. So I cannot give you the guarantee that if you reserve one H100 by one H100, I may first time when you reserve H100A1, you may reserve it at one node. And then 2 days later, then you reserve H100A2.
Okay. So then I think the load bearing body is. So when you say reserve, what do you mean?
It's reserving as a GPU in the platform. So this is all actually running in our Velocis platform. I'll show the demo. So while you are, I'll show the demo, then you will actually know automatically you itself can able to go and reserve the GPU on demand basis, something like
So
that.
say I reserve 2 GPUs at the same time.
Yeah, if you say, then it will be in the same node. Exactly, correct. And or you can actually specifically give us the requirement. Say, hey, I have 6 GPUs. Make sure that it is all sitting in a single node. But if you don't specifically specify that and just go ahead, I'll show the demo. Just go ahead and click, and then reserve. It internally it will actually see wherever the GPUs are available, and then automatically it gets allocated. Yeah. Because yeah.
Another question which I have is, so sometimes what we actually have is very large data sets.
Right.
And all the users actually work on the same nets.
Okay.
So is there a shared memory sort of option?
Yeah. Okay. Shared memory, if you want the shared memory, that is where the PFS actually comes. PFS is mainly for the shared memory. But in the virtual platforms, so where your existing GPUs are running, we don't actually provide the shared memory per se with the PFS. So, but we also provide the storage, which is a Ceph. So there, all that is actually runs in a millisecond. Basically, PFS works with the microseconds. Ceph actually works in a millisecond. So we can provide you the Ceph storage, where each of the nodes can be actually mounted to. So for example, H100A1, when you are reserving this VM will be mounted to my storage, whatever I'm actually providing. So all of the users who are actually access to this specific resource can access that mount as well. Right.
So that way, data sets don't have to be.
Correct. In this case, one VM to, for example, if you say H100A1, that's a VM when I say virtualized GPU. That is connected to the storage. But in the training case, in the cluster previously in the morning session, we saw that the PFS doesn't work with one GPU only. It needs to work with all 6 GPUs. All 6 GPUs need to access to one single point at any point of the time also. So that is a bit different. You getting what my right? Yeah. Right. Yeah. Right. Oh, okay. Shared space. Yeah, I mean, as long as they can able to access the VM GPUs, the same privileges will be going for the storage also. So you're saying that even though I give my access to 2 users, second user, I don't want him to delete from the storage.
Yes.
For this, I need to think and come back.
Okay,
So
so-
right now, how it works is the privileges will be passed on to a VM to storage as well.
Okay, slight modification. So let's say I just want students only to read, but as a pseudo user or something else, admin, I have the read right.
That one you can
That
do
can
it.
be done.
That one you can do it. So you can actually remove all the users with the right access, except the admin from this one. But you want to actually allow only some users for the read, some users for the write. That one I need to check back how we can able to control that. But only to give the read access, that one you should be able to do that. So yeah, so this is on the high level platform, and I'll walk you through the Velocis platform. So this is our Velocis platform where we actually spin up our GPUs. For example, as we were discussing earlier, that if you want, for example, like 4 GPUs or 8 GPUs, what we do is we get to this platform. So in this, there is an option for Velocis Hub. If you go to Velocis Hub, there are different options are there. So we are bringing the bare metal also into the Velocis platform. So which means you should be able to, in the next 2 months or 3 months, as long as you have access to this platform, you should be able to do access. You can actually reserve your bare metals also. That feature is actually upcoming, but today we are actually working on it. I don't have any bare metal, that's why you don't see it here. But mainly our focus is on the virtual machine. So this is what actually you are interested in and wants to create it, right? So first I'll walk you through the virtual machine. So if you want to create a GPU, click on this virtual machine. You will see different types of GPUs with a SKU, each of the SKUs available. For example, it's a H100 NVL. which comes with 94 GB of VRAM, right? If you go to, and there are different types. So ignore this pricing, this cost and everything. This is a staging setup. So this pricing could be different than whatever you get. But you see MRC is like monthly commit. Whenever you see OD, which means like on demand. So you want the hourly basis or day basis, you go with ODP. So there are several GPUs are there. You can see H100, SXM, 200, L40, L4. So these are all the VMs that I can able to, it's ready and I can able to reserve it. So to keep it simple, I'll just spin up a GPU and then show it to you. So you can see that I'm going to run L4, which is the smallest GPU, 24 GB MRC here. So once you click on this, you can give any test GPU. I hope maybe I'll just put GPU1 because I was testing. I don't know whether I have the same instance name or not. That's why I just give the unique name, so GPU1. And once you select this queue, you can see that what exactly the configuration that you're going to get. One GPU with the 24 GB of VRAM. And this is the CPU, RAM, and disk space. Disk space is 100 GB of NVMe. By default, it comes with. So what you are actually seeing here, the Slurm head is again other different. That's different, and this is different. So each one will have its own storage space. This is the disk space. And you can select which Ubuntu machine that you actually want to. The recommended is the latest 24.01. And if you want the public IP to be assigned to this VM, you can actually do it. Otherwise, you can access with the private IP also. So for now, I'm just creating a public IP.
Can you customize this?
Sorry?
Customize.
From the GUI side, you cannot actually do it. I don't think even if you for the bare metal only you can able to do modification, but even with the VM based option also you cannot actually do the customization. No, at the moment we are validating other OS. Like other than Ubuntu, we are validating some other OS, RHEL and this one, but custom OS we don't have. So in the access management, either you can access with the SSH public key or you can use login password. So I'm just giving random one login password. By default, this VM is actually blacklisted with all the IP address and ports, which means nobody can able to access this GPU by default. But you should be able to give your subnet based on your request. So right now what I'm doing is I'm giving access to do the SSH to this VM across the world. So I enable 0.0.0 for the CIDR and for the only port is SSH22 port, right? And the metrics agent is enabled. So when you enable it, basically you can able to come back and monitor your GPU also. So once you're done, then you can do the deploy. It will take anywhere between like 5 to 6 minutes. So this is successful. So you can see that instance deployment is actually pending. So it will actually go ahead. Okay, but in 5 minutes it will be done. But meanwhile, you can see that the one that I already created, which is here, this is also I just created for this demo purpose. So there is a public VM. All you have to do is just, oh, okay, I need to share this as well. Just a moment. Yeah, so I hope you can able to see my screen. Internet is accessible, right? Internet is not there. Okay, it is disconnected. It seems. Is there any firewall or anything is there from your?
That over Wi-Fi
Oh,
get blocked port.
Okay, okay. Maybe I need to connect to the hotspot and try it out. So maybe your firewall is actually blocking.
Sometimes they block the port 22
Oh, okay, okay, makes sense.
over Wi-Fi. Right? Over Wi-Fi, sometimes they don't allow
No,
SSH.
they have blocked access to any IP address. Whenever we mention certain, for that only they have whitelisted. Like 800 and plus thing.
So outside, I cannot access any. No, I could.
Now we have opened the IP. any idea?
Yeah, but the problem was not on your side. I think it's on.
I'm connecting my hotspot. Let's see. Okay. I connected to my hotspot. No. Okay. Now you can see that this is what I was telling. So because I created with the login password, I have the root sudo access by default. Anyone actually wants to make changes and enable the flags or anything in the GPU, and then actually they want to track the power and all of these things, what they're actually consuming and how much they're consuming, all of these things you can able to monitor from here also, or you can I mean, if you have the sudo access, or you can actually go back and check here the view metrics. Based on right now, no models are actually running for me. So that's why you see it's actually by default, it sits with the 16 watts of the power. No models are running. But if you see any models are running, this loading, this GPU Grafana page will also be spin up, just like how you're seeing for the CPU utilization, right? I think it will take some time, but it will show up. So that's actually on the quick demo of virtual machines part. But we also, I just want to, since we talked about the bare metal, we also have the virtual machine. The third option, we also have the Kubernetes cluster, which means you can actually create your own Kubernetes cluster pod. Depends on how many master nodes that you want and how many worker nodes that you want. So each GPU that you are actually selecting, I'll show you here. So you go to the new Kubernetes engine, select the Velocis Kubernetes engine here. So test Kubernetes. So I have selected HA, which means there are 2 master nodes will be there in this Kubernetes. And once that is done, you create you select the latest version, and you can actually select how many worker nodes. First, you need to tell what is the GPU that you want, which is the selection of the GPU. What's Q-L40, L4s or H100. Let's say I select the L4. You need to tell how many worker nodes that you want. So same L4, you want to replicate it in how many worker nodes. So let's say you select 5. Okay, which means 2 master nodes, 5 worker nodes will be created, and 5 GPUs will be in the worker nodes. And then you should be able to, just like how we spin up virtual machine, you can deploy this as well. So this is for the Kubernetes cluster. So any questions so far?
Hello, yeah, am I audible?
Yeah, Aditya, please go ahead.
Yeah, so for example, say I have a team of 15 people, you know, and if I want to create an instance which I myself will not be using and someone else will be using, so I can just create a virtual machine and take the SSH and the password and give it to someone else, and they can directly access it without the credentials to the Velocis platform.
Yeah, they can. I mean, we don't recommend you to give the password. Instead, you need to create a public SSH. Please create a public SSH key, and that public SSH key you can actually share it with your 15 students. That would be more secure, and they can able to access it with their public SSH key.
For example,
I'll show you
if
here.
I want to create multiple instances and give it to different team members.
No, a single instance you want to share it with 15 team members, right?
So there are 2 use cases. One is a single instances which would be shared between 15 people, and the other would be multiple instances shared to different individuals.
Yeah, I mean, in either way, you can actually go ahead and create either 2 things. So you can see here under the IP address, under the access management, there are 2 ways that you can actually provide your access of your VMs to your students. Either it is a single VM to multiple people or multiple VMs to multiple people. Recommended way is to create a public SSH key, and you can actually add the public SSH key here so that they can able to access it. Providing the login password is always be critical because it's a plain text. We recommend only admin access. Admin will have the login password, but other users who are not going to be admin, they can access it with public key.
Yeah, okay. And so for this, only the virtual machine instance would do the Kubernetes, and that all is not required.
No, that is not really required. No.
So what is the purpose of the Kubernetes and the other bare metal systems?
So that is for GPU scaling. Let's say today you have a requirement inference of 2 master nodes and 3 worker nodes. Right now you are doing the inferencing, but suddenly your GPU workloads by tomorrow, you're actually, some example, let's take example, Great Indian Diwali sale is going on, and your requirement of inferencing is going to pick up for the next 4 days. Then you need to scale up, right? So you need to add more worker nodes. Dynamically you need to add it, and you can scale your inference. And then once that Great Indian Diwali sale is done, then you can actually turn down those worker nodes. So that is the main purpose of the Kubernetes. It's actually for the GPU scaling and scaling up and down.
But from a training point of view, that is not required. A virtual machine should do, right?
No, not really. Yeah, from the training perspective, Kubernetes is not the one also we recommend. Kubernetes actually for application deployment and like this, like inference up and down or managing the utilization. But for the virtual machine is more than sufficient enough for training as well as the inferencing also.
Just a small point to clarify on, the virtual machine is for a node or for a GPU?
For a GPU. A
Okay,
node,
it is not on a node level.
No, not on node level. Okay, I'll show you that. So you can do it on the node level also, but virtual hypervisor is always runs on the GPU level. I'll show you here. So if you go here and specifically select the SKU, okay, I cannot change this because it's already done. H100. This is all single. So you can see this is a single H100, which means virtualization of the VM is done at single GPU level. Now, if you see here, this is 2 GPU level. Similarly, if you go like it's 4 GPU, and we also have other SKU, which is not showing up here in the staging environment, which is 8 by H100 also, which means technically you can say that is a VM over your entire node. But if you go and see at where exactly this hypervisor is actually sitting, it actually sits under the GPU level. It wraps around the GPU level.
Yeah, so just to come to the first pass of the presentation, say we need 8 nodes of AMD.
Right.
So the way to access that is directly through the platform, or like do we talk to and you have to do some separate thing for that to get that available?
Yeah, for that, the morning session is mainly on the AI training part. That is a bare metal one. For that, you need to actually reach out to us. We physically take out those bare metals and physically need to do the physical cabling and everything. The platform one, whatever I'm showing, we already did the pre-work, and already we deployed some of the nodes, some of the GPUs already readily available for you to on demand. You can able to consume it. This one, when you actually go and reserve it, as Aditya was asking here the question, so when you reserve it, I cannot guarantee you. For example, you go and reserve 4 H100. This one I can guarantee you that it is going to reserve it in single node. Let's say you are going to reserve this 4 by H100 8 times. I cannot guarantee you that I'm going to use only 4 nodes. I may end up using 8 nodes also. These 4 by H100 can able to split in other 8 nodes also. It depends on my availability in the platform. That's the difference between a bare metal and the platform virtualized one.
So you're saying even the physical GPU, even if I have reserved it for the virtual machine, there can be a logical partition in it which some other user is also using at the same time.
Yeah, correct. But if you do it from your side, yes, from the GUI side, if you do it, you will do it like that. But if you tell us, hey, I don't want any other users actually using my nodes, then we internally, we know that each node will actually have the host name. We make sure that when you are actually reserving this 4 by H100, we just reserve only that node, and remaining 4 GPUs, we can actually leave it empty as well. And then in future, when you want to actually increase your another 4 more nodes, we can give it in the same node as well. Because this is in the backend, we have to check the chassis ID and everything we need to do it.
And what exactly has been reserved by our university? Is there some prior arrangement about what has been reserved, what is not available?
So sorry, I didn't understand your question. Can you repeat your question again?
So as far as I can see, this platform right now is on a pay-per-use basis, right?
Yes, correct.
So my question is, has the university made some arrangement so that certain nodes are reserved for the university which we can access, or we have to separately do it?
So actually, from Neysa side, we go by monthly commit. I think Siddharth will actually be the right person for the commission. But to answer your question, yeah, university already have some reserved units from the virtual machines. So that's what already have it for, I think, 3 campuses and 6 GPUs virtual machines is already university reserved it.
Can you tell the technical specifications of which GPUs have been reserved?
So that is
Dear Aditya, this is Srinivas from AppCare team. So we have taken 3 VMs, which is having H100 2 GPUs each and 10 TB storage for each campuses. So this is explicitly only for AppCare faculties and research scholars. So the details you can visit AppCare website, and under cloud service section you can see the details, all details like specification, how to use it, everything.
Yes, Srinivas, sir, it is clear to me. Thank you.
Thank you.
okay. Yeah. Yeah. So I think any questions on the demo?
No. Okay. I use it. The prices don't matter, but what I mean, say as an individual user, I want to use it for 2 days or 3 days, can I?
We do buy points. We have an on-demand model as well. They are about 700 I charge the months. Okay.
So for the kitchen rate, it would be 50.
Financial it will be about 70.
So that's the minimum commitment. Okay. And if I use it for the whole month, I will be paying.
Then you will be paying about 125.
That's
They don't want to use it for 700.
Not exactly twice, but yeah, 1.1, right? 1.5. Okay.
That's for platform.
Okay.
200 hours.
That'll be about 70. The thing is, when I'm giving you a particular game, then to put it out, so that when you're not using anything, available when you want to use. So I at least need to cover my cost for running the VM for an entire month. Just $200. That's what I'm taking from.
The other question which I have on the technical side is, so this is all, and like I'm assuming that when we are running the jobs, we'll be submitting it through Slack.
Right.
How does error logging, and
Yeah.
there were other loggings work? Where is the logs stay?
Right. So okay. Actually, from Neysa side, we don't give any log management. That's on the. I just want to be clarified. But usually, what we are actually seeing in other customer, even today morning also, we were actually doing some troubleshooting for training. They are actually doing post training model. They are actually doing with 200 billion, but it's not complete fundamental training. It's a fine-tuned training is what they're actually doing. All the logging, they actually keep it in. They have the separate storage. They actually took it, which is the Ceph one, not the PFS side. And they actually save all the storage, all of these things logging over there. And the eventually the older logging, the archival and everything, they actually wanted to do it. They're eventually they're moving it to cloud-based cheapest tape logging. So basically, we don't have the tape storage, which is the cheaper archival storage, right? You will actually get like 20 to 40 cents. That's all per GB, right? It's super cheap. So yeah, if I'm not wrong, no, not 20 cents. I think the 40 paise per GB is what archival is for in the hyperscalers. So they're eventually after 3 months and every log is actually gets saved, and they are actually moving it to the archival tape storage.
So regarding the same thing, another question is, so short of, I mean, say I have to run a same trip or
Yeah.
some which might be quite
Right.
different from the standard train. I mean, say, how do I know that it's not, say it's working on my engine,
Yeah.
but say I want to deploy it also, like I want to run it for the longer epochs on this term.
Yeah.
How do I know that, I mean, whether it couldn't error on, say, 98 epochs? Like
Oh.
after running a long time, there would be an error, I think. How do I avoid?
Yeah, actually, I haven't tried that. So I'm actually, I don't have the better answer for that. But I don't think Slurm can able to do that. Slurm can able to do only look at the resources, and based on the resources, it will allocate the job. That's it. But what you are actually asking is at the 90th epoch or the 50th epoch, how do I actually envision that where my resources can actually crunch into, and then
Not exactly the resources crunch, but say, I get an error.
yeah.
Like, okay, so one of the standard errors I used to get a few years back is internet did. We used to log rates in WA.
Okay.
And if the internet got disconnected, this coding, the training run used to stop.
Okay. Yeah.
So these kinds of stuff.
Okay. But you would be doing checkpointing each epoch, right? Yeah.
Yes, but I mean, say, like, would it be possible that, say, like, how would I, first of all, first I need to know that the entire, error log has come.
Right.
Like, how do I know that trace back errors? Because Slurm didn't used to give us.
Yeah. Slurm will not actually do
tell
that.
me the exact errors. All I will see is.
So basically, you're saying, okay, manually. So manually, is someone actually disconnected it, or is it because of the internet, or what exactly the error that epoch has actually failed at? So yeah, from our Neysa side, we don't do it for sure, and Slurm also cannot able to do it either unless that I actually do the logging. And every time epoch, actually, I try to do it. For example, each and every use cases, like for example, network, I try to log in. I need to actually do the logging by creating the logger. That is the way, but
Yeah, that's the software engineering.
way. But at least from Neysa side, I don't see a possibility. Let me get back to you on this one. Let me think through, and also let me see what our other customers are also actually trying to deploy with. But today, what they are actually doing is checkpointing, and whenever the problem happens in the training, they go back to the previous checkpoint and then continue. They're not spending time on what exactly the troubleshooting. If the checkpoint again restart is not happening, they directly call to Neysa. That's what is happening, right? So, that's what we are actually seeing today. But I'll get back to you on this logging part. But
Yeah, I mean, because sometimes the errors can actually be quite weird.
Yeah.
Especially in our.
Right. So how do we capture 360-degree of the error in a logger file if I am actually coming up with my own logger? Right. Something like that.
Yeah, I mean, from the software engineering, yes. I mean, I think I have read enough
Right.
to know. But Plum,
Yeah.
say that, say something, some error is about to happen.
Right. Right.
That's not stop it. Or,
Yeah. So
I
maybe
mean, more or less, I need those, what do you call, not logs exactly, but like, did it fail? Like, for instance, internet failed.
Yeah.
I could never even have known in the log.
Yeah. Correct. The internet. Yeah. True.
Right. So those kinds of things, how could I do?
Yeah. Let me think through. I mean, I don't have the answer at the moment, but I'll actually get back to you on this one. Like, what is the best practices? What are other guys are actually doing? So that would actually give better sense, I would say. So maybe I can check and get back to you on this. Yeah. So so that's actually on platform demo. So this is the high level architecture view that we have. Aditi, you have a question?
I don't have a question. It was just like I forgot to lower the hand.
Oh, okay, sure. So yeah, so this is our actual stack, what we're talking. So whatever you see actually on the infra level, and we also actually have the Jupyter Notebook as a platform as a service, and we also provide the inference as a service also. Today, you're actually getting VMs, and of course you have the Slurm job training and fine tuning. It makes sense to go with the infra level and get the virtual machine. But some of our customer, hey, I don't want to touch the virtual machine. I don't know how to do the model deployment also, but I want to still use the models. So then they actually go for the inferences service. They tell us which model to deploy, and we deploy the model, and they can directly make an API curl call, just like how do they do for OpenAI and Claude. So these are the three types of stack. So just to give you the mental model, what exactly the platform actually provide. First, we create a VPC for you, and inside VPC there will be two space. One is workspace public and workspace private. You can actually create, which means you can in the platform itself you can create a users, and in the users you can create a segregation that who can able to access what, and each workspace can able to provide with virtual machines, and also we can create Kubernetes cluster also. We can also provide the inference API endpoint, and we can provide the Jupyter notebooks. It's all comes under the single VPC cluster, and VPC cluster is secured by our firewall, enterprise grade firewall here. And on top of that, you can create your projects, and each project you can control the rollback access control, that which project, which user, and whether he has access to that VM or not. But either you do it from the Slurm side, you are actually doing from the training perspective. That's why you control that access and everything in Slurm side. But if you want to access if you want to control the access of the user, like what Aditya was actually telling, I need one VM, I have one VM and 15 users are there. How do I control that which user actually having with which privilege, whether he can able to access that specific VM or not? So those are the things you can control on the platform side as a RBAC. Right. So that's actually on Neysa side. So I just want to touch upon some of the trends and evolution. I think you guys are already familiar, but I just want to touch what are the problems that we are facing in the industry. One of the main problem is the memory wall problem is what we are actually facing. As per Moore's law, you can see that every 3 years compute is actually getting double and double, but our memory and memory bandwidth is not actually catching up. So that one, the problem is what we are actually facing is there is a huge gap is actually getting created, irrespective of you can able to do. So most of the time your computer is getting sitting idle if you cannot able to get that memory bandwidth right and then fetch the data and put it in the computer, basically, right? So how we can able to, this is the reason both the sides, one is hardware side and also software side, both the side needs evolution to cope up with this memory wall problem what we are seeing. What trend that we are actually seeing after B300, we are having like Vera Rubin. So this Vera Rubin is actually coming with bigger HBM bandwidth. So you can see H200 comes with 3.2 terabytes, and B300 comes with 8. And here you can see it's not double, it's actually like more like 3 times, because they know that this memory wall bandwidth is memory HBM is actually, we cannot actually put more HBM there, but at least if I put more bandwidth, the speed at which I can able to transfer my bytes from my memory to the compute can be actually increased. So that's the reason you see that it's not just like 3 times almost it has increased, like 22 terabytes per second, and it's, I'm talking about per GPU level. And also if you see that petaflops already it is double, more than double. 15 petaflops you are seeing in B300, it is like almost like what 5 times 4 times than B300, 5 times B200. So basically the whole idea is GPUs also is actually getting better, and according to that bandwidth is also getting increased. And one more point that you also should notice is, morning Zay was actually telling, if you want to go for Grace Blackwell, you need to go for that entire NVL72. Similar concept for Vera Rubin also, because even if you go for the entire the rack itself, then only this memory wall can be actually cope up with, because whatever the model that it is actually coming up, like in terms of trillions, that one, even actually I increase it in the GPU level, people who are actually can able to afford one node still cannot able to put the trillion. So unless I actually can able to have the whole rack. So Vera Rubin is also going to the NVL72 way. You may ask a question, what's the future look like? I don't know, but it's going to be damn expensive, just like Grace Blackwell also. So either we should stick with Grace or Vera CPU, or we should go with Intel CPU with the GPU. So that's actually comes with one node, right? So that's actually on the hardware side, right? So the software side is actually on the LLMs. What are the some of our customer largest fintech in India? They're also in wallet provider. So they are what they are actually doing is they are actually using these two things. I think you're already aware. One is better architecture. I think the second one is the KV cache. We are actually getting tighter and tighter. But this is something that what our industry best practices our customer is actually doing. One is the speculative decoding, which means every time I have a model, why should I rely on the bigger model? I can also have a smaller model, and that smaller model can able to predict the token faster, and this bigger model will actually verify whatever smaller model actually done. So that is actually speculative decoding, right? This multi-token prediction, and there is another one called disaggregated inferencing is actually done by one of the fintech customers. What they are doing is, why should even we think about a prefill compute as well as the decode in a single GPU or single node? Instead, what if I split that entirely, the prefill and the decode, split it, and then all the time the prefill actually runs in single node. Full node will be used only for prefill, and full node will be used only for decode. And this node of which is actually doing for the decode part, that one actually going to run it in the edge inference, which means, for example, let's say I have a headquarters, clouds data center is there, which is sitting in Delhi or Mumbai somewhere. Every time the compute happens, that compute happens there, which is the what are the pre-fill things, inference comes, but the decode happens at the small model level, which is happens at, for example, my customer is at Chennai, and I can have a small node which can able to like L40 or some other small node, and decode can able to serve only that, just like internet. So we are actually looking at that. We call it as like a distributed edge inferencing. And NVIDIA already proven it. So for that, some of the tools are like NVIDIA Dynamo and LLMD. It's actually doing it at the scale. So because India is a big country, that we cannot actually have like all the nodes, and whenever every time my customer is actually inferencing only, that's a decode heavy, memory heavy. But in most of the time my compute is sitting idle. Why should I even pay for the compute which is actually sitting idle? Instead, if I split it, that compute I can use it for something else, and the decode part, I will, based on the sizing, I'll use the decode and I'll go for the smaller nodes. So this is one of the that actually comes under the distributed disaggregated inferencing, and also the multi-token prediction. Also, they are actually doing it. Right. The third one is the diffusion LLMs. I think you would have heard about the diffusion LLMs. Instead of we go with the auto-regressive pattern, every time my T2 comes, and the T2 will multiply it with the KV cache, and then I come and go and predict the next token. Instead of that, in the diffusion case, I will predict series of tokens in a way. I'm okay if it is wrong also. That's why it is actually step, you see the noise is there. I'm okay with that. So even though it is wrong, but the next iteration, I will remove whatever it is not making sense for the context. So I will do multiple iteration. So at least it is actually way faster than auto-regressive. So for example, if I have to predict 100 tokens, auto-regressive is actually using 100 iteration. Each token is to go through again forward and backward. But in diffusion case, it's not going for 100. It is like 4 times it is better, which is using 20 times. It predicts all the tokens at one shot, and then it will correct each token randomly, like same, just like an image diffusion, stable diffusion. So this is also something we are seeing gaining traction in the market. So yeah, I think that's all pretty much from my side. If you have any question, please let me know. Otherwise, I'm good.
So say I want to use Kerma.
Right.
So for that, I have to deploy 24/7 for an entire one that user.
Yeah.
So the inference as a service.
Yeah.
Do you charge per token basis?
No,
per hour
we
basis?
all go by per GPU. So none of our services are from per token basis. We all, because from Neysa infra side, what we see is what is the cost that we are actually incurring. Like for example, if I'm deploying GPU for you, the power and cooling is what I pay for, and that is what you are also charged with.
So any of your customers are using your infra to say, sir, these open source models?
Yeah. So I cannot name them, but it's actually one of the fintech. Yeah, they are using it.
I'm not saying being serving for their own setup, serving for general say end users like.
Yeah, that's what I'm saying. So not okay, not the retail customers, but they have that. It's a B2B. These customers are B2B, so they are also insurance providers, space NBFC. So they are actually giving it to their customers. So as a service.
So not as a retail. So
Not for the retail.
Who is doing retail.
At least not in India. So in India, I don't see any people. I mean, most of the people who are actually giving it for retail is like open router. Everyone US based one. In India, I don't think anyone is doing that. Is it anyone is there as per your knowledge? I don't see at least anyone.
No, and we also wanted that. Actually, we are also looking for an Indian vendor desperately because.
Yeah. I think. But I think someone needs to have a burn the cost. But I think US have big pockets to do that. Like OpenRouter does it. They give it like on ChatGPT, OpenAI. They're all. I think in India, I don't see at least any vendor. And also we are like cost sensitive market. So
It's actually very cheap and it's actually very good.
Right.
The only reason I don't want to run it.
Okay, Super U. You can actually try. Yeah, I think if I'm not wrong, they are actually doing on their voice. Their deployment is not on us right now. We are in the talks, so that's their name. That's why I told the client name. But but yeah,
I don't need.
Yeah, but they are actually they're doing it for TTS, voice based ones. You can actually use it. They're actually having a models from 11 Labs for the auto speech. I think they have so many things. Super U, you can try that. Yeah. Right.
So one of the things which got pretty famous is the open claw.
Yeah, open claw. So OpenClaw, not really. I mean, you are asking like a service, like OpenClaw itself is actually packaged VM service.
A VM with all the requirements for OpenClaw.
Yeah, we are actually okay. Based on my discussion internally with engineering, they were actually even asked not to use OpenClaw because we are in the data center space, and there can be like security breaches can actually happen if even my laptop got affected. It actually can actually affect our. I mean, any sensitive information also can be lost. But that's something we need to see. I mean, there is a lot of security details also is missing out.
Say I'm taking the VM
and then VM has the open claw. Yeah, right. That shouldn't. Yeah. I agree. But at the moment, right now, we don't have one. But I think it's nothing stopping you also to take that one, right? Because our VMs will actually come with CPUs. All you need to CPUs. You can actually do the installation yourself also. And anyway, you have the GPUs that mod can actually host it in the GPU, which can OpenClaw also can able to use it. So
run a Gemma 4, I think L4B is
if you are okay with concurrency is low, it should be okay. I can post this one. I have the benchmark. I'll share with you. I'll share with you right away. I can do that. We did the benchmarking for again a biggest UPI vendor in India, and Gamma 4 is actually one of the requirement. They want to move from OpenAI's GPT OSS 120B to Gamma 4. They are validating. I'll share the benchmarks after this. Right on.
Thanks. I know.
Yeah. Thanks.
Thanks.
Yeah. So how do I send you that details, like Gamma 4?
Should have the
I'll do it.